So how can we do that? Using the transaction. Transaction is the what? Logical unit of the processing. What is a physical concept? Physical unit of the processing. Read and write the data. Okay? Operating system read, write the data. It's a bunch of the combination of such a read and write. But sometimes when you read the data, when you write the data, it's not just one operation. It can be many operations for one application. That group is considered as the transaction. So when you are saying, so sometimes transaction can be when you log on the system, use your the transaction start. Okay. Then when you confirm of any change, like the transfer or the something withdraw the money or the deposit the money and the confirm, then that is the end of the transaction. That should be, no matter what happened, that change should be applied. How can we do that? At the time, we can log such a transaction, not the change in data. Change in data, the new data will be cached. Okay? If you the permanently apply to the hard disk drive, it will take a longer time. So you do not. You just change the data in the memory. The problem, memory is volatile. Without power, it will be gone. You may lose even apply the data, change the data. So how can we keep? We just keep the command, transaction information, logical concept. So if we back up this data, we don't have backup or change data or before data. Instead, just such a transaction information. If we have such an information, when we restore, when we recover the system, we can reapply such a transaction. Okay, that is the.
No, but if disaster happens, then how are we going to record the transaction?
That's a good question. I actually just the overview of that part, but I will give the one example how it works. So our data file is one. We have the transaction. That transaction change 1 to 2. Okay. Then this block is changed into 1 to 2. Right? Where? In the buffer cache, as we have discussed. That is the way of the buffer caching to speed up. If we can write the data directly, hard disk drive, just as we have seen before, it's very slow. Okay? Instead of writing the hard disk drive, we can update the disk. Problem? Oh, so let's keep this one. This is 1. But problem, if the system crashes, we lose such a data. So to address that problem, when we execute the transaction, this information TX transaction change 1 to 2. Okay, this should be logged. Then after log, this one transaction will be completed. In terms of database, this is called commit. But in operating system, does not use such a commit. Instead, it's completed. So at this time, what about this change in data? Eventually, it will be written to the hard disk drive. When system has the not very busy, it has either the resource at that time it can write. It's called the deferred write or delayed write. Okay, but problem is before writing it's updated, but system is crashing. Still 1. Supposed to be 2. But when you restore, it covers. If you back up this one is in the hard disk drive. If you back up this data, when you check the consistency, check whether this block is 1 or 2. It's supposed to be 2, right? But it's a 1. So you can apply this transaction. This is called redo operation. I need to explain again that I did in the database code. There's another one, undo. Similarly, transaction is not completed. So it's supposed to be still 1. But there are too many updates. Even though transaction is not completed, it's supposed to be, I need to change it to. But transaction is not complete. It should be 1. But no space, no more space in the memory buffer, so we update database. But still, in this, it's a 2. Okay? Then, system is crashing. What happened? It's supposed to be 1, but it's a 2. When you see the log data, this transaction is not completed. It's issued, but not completed. So which means it's a go back, undo. Okay? Original data.
And this hard disk is on the same computer or different
It
computer?
doesn't matter. Okay? But we assume this one will be alive. Alive means backup. That is the reason when you back up the data, backup log data is very important.
So we first log the data and then we change the data.
Yes.
So always it just goes.
Yes,
logging
that
first.
transaction will be ended with such a log the transaction information. Not change the data, but the operation itself should be log. That is the log structure file system. So that log structure we can have the separate file system. Sometimes there is a log file system. That is a concept how log is working for the transaction and recovery the system. So the next one is the network file system. What is the main difference between the file system systems that we have been discussing so far and network file system? Basically same idea, but the file is located, physically data are located remotely. Then we connect such a data through the network. So most operating system nowadays use TCP or UDP protocol for that connection. Problem is, everything is fine, but the problem is, do you believe the network is 100% reliable? No. You may lose the packet every time. So it will be whether or not you realize packet is recovered or you lose some network information and resend. So that is usual. Similarly, when you access the file, if you lose some information, so you cannot use such a file system. Also, do you guys need to know everything about where the file is located? Even the local file system, you don't know. Instead, there's a layered approach. So from the symbolized address, it will be eventually changed. What about the network file system? So transparency is also important issue. So network file system, the file is physically located other, then we can mount to the local directory. Okay, that is called the NFS. At that time, we can use the. Do you remember that RPC, remote procedure call? So between you can execute the command for operating system calls remotely. Okay, at the time each one has the sub, so that the receive and execute the command. So remotely you can copy the data. Okay, at that time you don't have to worry about what's the network configuration. It's between the network, so you can submit the link. We can use such a RPC protocol for the NFS. Okay. Let's say that we have the 3 file system. Server U, name is the name, server name, and this is another server name S1 and another server name S2. Then if you mount it's S1, okay, S1 the slash USR slash shared into the U under USR local. So this part should replace this local. Okay. you still keep the local directory, but you may lose the information under local. Instead, this remote file system will replace this area, that is this mount. You can actually, to establish the network file system, you can mount the remote file system. What about the cascading mount? If you mount this one to the S1, okay, then from the U side, okay, from the U does not know whether this is mounted or not, network mounted. As the S1 is mounted, S1/US shared DIR is mounted by this DIR2, then it's cascading the mounted, that is the cascading mount. So network file system provides such a transparency of the network mount. So this slide shows the overview of the network file system architecture. So this is the one server, this is another server. So this one is called the server, okay, that has the NFS server, and this one is client mounted this one. Both of them has the virtual file system. Virtual file system will be used for the common interface for several different file systems. So even from the other Unix file system, extended file system, they can access the file located in the remote file system without any other. That is called the transparency. So it provides the transparency. At the time, the RPC is used for to run any operation. Okay, like the copy the file, search the file. Okay, at the time we can use the RPC protocol. Over the TCP or the UDP will be this layer.
Can you explain mounting again?
The mounting, we learned about the local mounting. If we have the local file system, it can be mounted to the mounting point. Mounting point means a directory. We can do the same thing for the remote file. So this is the different server. Server U, server S1, server S2. Okay? Actually, the S stands for the server, and this is the user client level. So we'd like to mount the shared /dir to here. Okay? Then at that time you can do the same command, mount, but you need to provide S1 mount. The mounting point is U /USR and local, and this is a mounting point, and the remote file system will be mounted here, then it will be like this one. Also, if you mount this S2, DIR2 into DIR1, okay, then from the U side, it will be automatically, cascadely.
So it doesn't change the name,
No.
it just changes the type.
Yes. Because the name itself is the mounting point, it's local. But on the local mounting point, the other data are remotely NFS. Okay. Then from the client side, the user side, no. Whether this is a local or the remote. Okay, that is a transparency.
Should go back one
Yes. Okay, so this is slide, the overview of the such an NFS mount. Okay, I'm going to skip the example of that file system, WFA. Actually, WFA I never used, but this is the long time example of this textbook. I don't know why he likes this one, but anyway, pretty much enough. So next week we are going to finalize the operating system with the chapter 13 IO management. Okay, also the problem. Hopefully we have a time on Thursday. At the time, I'd like to quickly review of the second part of the semester for your final exam. Okay, not miss the next week class. And also our exam is the May 7. I think the Thursday, not this room, 107. Okay? Dana 107, not this room. Yeah, Dana 107. So 이거로 those who are taking engineering 400 today is the same room.
It's the big.
Yes, right.
What time?
Also 1:45 to 3:45. Okay, so I'm going to end today's class earlier because I have engineering 400 who will see the